Okay, let's come back here again, and let's just see what we've got here. Okay. Now, we have experiments. Now, when you conduct an experiment, we try to design an experiment to test some idea or some concept. You make observations. Okay, you observe, you measure things, you write down your results carefully and coherently. You document all your results, and you document your analysis. You're going to hand in an analysis of each lab. Some of those analyses will be in great depth and some will be more superficial because there are a lot of labs and we don't want you to spend all your time writing labs, but you will spend a considerable amount of time analyzing and reporting what you have. And you quantify your errors because there are errors in any experimental process. And we want to see how big those errors are. So under experiments, we have design, observation, documentation, and quantification of errors. Now there's analysis involved with experiments, and we'll talk about that in a minute. But we also have your introductory problem sets. Okay? And the primary goal of the problem sets is to teach you to reason things out. Reason out problems and understand through reasoning. Okay? Now the problem sets, if you haven't already seen them, consist of approximately 100 problems per course. And what you do with those problem sets is you basically learn to solve the problems that are posed for the course. Okay, now when you to solve a problem, you got to break the problem down. So we'd break down the problem. You ask yourself, well, I don't know how to get the final result. How can I get something? Okay? You draw some conclusion. Okay? Some logical conclusion from what you're given, and keep trying to get down to what it is you're trying to find. And in the process, you gain intuition and common sense about the concepts and the quantities that we're talking about. And you begin to conceptualize things. Okay? And that leads us down to conceptualization. Okay? To conceptualize, what do we do by way of conceptualization? Well, in this course we attempt to do a lot of explaining. There are a lot of questions involved with the labs and with the problems. We have to explain the problems. We try to explain what's going on in the labs, and that helps you develop a concept of what's going on. Okay? You try to understand things at the deepest level you can, which is a level at which things become intuitive and become common sense. You try to develop intuition and common sense about what it is you're studying. And you try to make your concepts consistent with one another. You gain those concepts from everything you do in the course. Everything you do leads to conceptualization. The lectures, the lecture notes, the text, all your lab experiences, all your problem solving leads you in the direction of conceptualization. Now, under analysis, okay, let's come over here and try to come in a little closer. Under analysis, what do? We compare the results of our experiments with the ideas that we had about our experiments, with our predictions, with our concepts and so forth, and see if the experiment is consistent with what we think is going on. So we compare the results with our concepts and our reasoning. And we make mathematical models. We model things. We use graphs. We use functions to create models. We use algebraic equations to create models. So again, as you'll see as we go through the course, these four things all work together to develop all aspects of the course, with an emphasis on the ability to solve problems, to conceptualize, and to analyze, and to conduct meaningful and precise experiments.